CSE department. A Karnaugh map is given with set of ones and zeros for a Boolean function f of w, x, y, z. It contains 4 variables. So for 4 variables, this is a 4 variable K map. And the question is, there are 4 expressions given below. What are the functions that rightly represents the K map given in the question? Now, in order to solve this, let us directly go for K map simplification. We have directly plotted here with w, x, y, z and given ones and zeros. Eliminating zeros, I have plotted only 1 here. If we group the terms, we get these 4 elements. If we group from row perspective, if you see, this particular group covers 2 rows, right? The first element is 0, here it is 1. Eliminating the different components, so w gets eliminated, only 1 is left, which is common, nothing but x. Similarly, for this group, it has 2 columns, it occupies 2 columns. So eliminating the first element, because these two are different, 0 and 1, we have the second element as common. Because it is 1, we consider the value as z. So this particular product term xz we obtain. Similarly, grouping the corner elements. So here this row, it occupies, the first element is different, so w gets eliminated. Because it is 0, it becomes x bar. Similarly, from column perspective, if we observe, the first elements are different, it gets eliminated. Second element is 0, so it becomes z prime. Because we have 2 groups, we have got 2 product terms. And if we check with the options given, it exactly matches with option D. Now we have 3 more options to verify. Because directly we have got simplified expression, and rest of the expressions are having minimum 4 variables. If we observe the first term itself, w, x, y, z, here also the same thing. All 4 variables are occupying the expressions. And comparing with the D, this xz term is common in all 3. If we compare, it is common in all 4. So according to this, if we can expand this x prime and z prime, the rest of the terms we must get. Only if this particular thing can be expanded to rest of the terms in options A, B, and C, I mean other than this xz term, it must be equivalent. If it is so, we can claim that those expressions also equivalently represent the given function. For that, what we do, first let us write the given expression, I mean the simplified expression x prime, z prime, and x is z. Now we are going to introduce a variable by ending with 1. If you end with 1, it's going to be the same variable x prime, z prime. Now we replace 1 with the help of y and y prime. So y plus y prime is equal to 1. So there is no difference it is going to make. Now expand according to associate law. So it becomes x prime, y prime, z prime. And second time it introduces y here. So x prime, y, z. X, z remains unaltered. Now if I check with these options, it is not going to match with, because only 3 variables are there here. Once again, we need to expand these terms by introducing 1. So if we introduce 1 as a product term, then that may be expanded through w prime and w. If I expand here, w prime introduced 2 times. Similarly, w gets introduced 2 times, right? So if I introduce w prime, it becomes w prime, x prime, y prime, z prime. Now if I introduce this w, the same with the first term, it becomes w. The rest of the 3 terms are same as that of the first one. Similarly, if we have expanded this, we have got 4 terms, and the last one, it is not altered. Now if I compare, option A matches with this particular expression. So we can confirm that option D and A are correct. Now we need to verify with the remaining options as well. In order to check that, first let us consider option B, because option B is also having very similar terms I have listed here. We just compare with option A. If we compare, the first term here matches, here second term matches with the third one, and here the fifth term matches with the fourth one. If A and B are equivalent, we can say that option B also will become correct. So to verify that, the unmatched terms in option A, I have taken to the left hand side. Similarly, the unmatched term in option B, I have made it into right side. So if these two terms are equivalent to this one, then we can say that option A will be equivalent to B. Let us verify this one. So if I check here itself, Wx prime are common for all three terms. So we eliminate on both left hand side as well as right hand side. Rest of the terms on the left hand side I have taken. So this must be equivalent to yz. Let us verify this one. If I take in this way, here z prime is common for both the terms. Taking z prime common, it becomes y plus y prime. So it is equivalent to 1. So 1 and something, that something will come, so z prime. If you compare z prime with the term here yz, it is not going to be equal at all. So option B is incorrect. So this option will be incorrect. In a similar fashion, we can verify option C as well. So first you write option C, whichever terms are given. Please list out option C. So if we list, it matches with these terms. The unmatched terms I have taken. Option A contains two terms. Option C contains one term. I have taken to left and right hand side respectively. Now I try to match. Only X bar term matches on both LHS and RHS. Eliminating this, this must be equal to the term on the right hand side. So let us try to simplify the left hand side. Here also yz prime, here also yz prime. Taking yz prime common, it becomes w prime plus w, which is equal to yz prime. Now the point is yz prime must be equal to y prime z. If you check with y, here it becomes y prime. Here is z prime, whereas here it is z. So it is completely undergo some contradiction. So our option C also incorrect. From this we can conclude that only option A and option D are correct. Thank you.